Welcome to our comprehensive tutorial on using InfluxDB for time series data. In this tutorial, we'll explore what InfluxDB is, why it's a great choice for time series data, and how to set it up and interact with it using Java. By the end, you'll be equipped with the knowledge to implement time series database solutions in your projects. Let's get started. First, let's understand what time series data is. Time series data is a sequence of data points collected at successive points in time. Common examples include stock prices, temperature readings, and IoT sensor data. InfluxDB is specifically designed for handling time series data. It provides high write and query loads, allowing you to efficiently store and analyze data over time. It's open source and has a powerful query language called InfluxQL. Let's start with setting up InfluxDB. You can install it on your local machine or use a cloud service. For this tutorial, we'll install it locally. If you're using Docker, simply run the following command. Make sure that Docker is installed and running on your machine. After executing this command, InfluxDB will be accessible on port 8086. Next, let's test if InfluxDB is running. Open your web browser and navigate to http://localhost 8086/. You should see the InfluxDB welcome page, which confirms that the server is up and running. Now that we have InfluxDB running, let's dive into how to interact with it using Java. We will use a library called InfluxDB Java to simplify this process. First, we need to include the library in our Java project. If you're using Maven, add the following dependency to your pom.xml file. If you're using Gradle, you can add it in your build.gradle file like this. Once the dependency is in place, let's create a Java class to connect to our InfluxDB instance. In this snippet, we instantiate the InfluxDB object and connect it to our local InfluxDB instance. We also set the database we'll be using. If the database does not exist, it will be created automatically when we write points to it. To write data points to the InfluxDB, we will now create a method in our class. This method creates a new point and writes it to the database. Each point has a measurement name, a timestamp, and fields. In this case, we are only adding one field, which is labeled value. Let's integrate this method into our main function to write example data into InfluxDB. With this main method, we create an instance of InfluxDB example and use it to write 3 temperature readings to InfluxDB. Each reading is stored as a point with the current system time as the timestamp. Now, to retrieve the data we've just written, we need to execute a query in InfluxDB. Let's create a method to perform this operation. In this method, we construct a query to select data from a specific measurement. We then parse the results and return a list of double values. Now, let's add this method to our main function to display the retrieved data. Here, we call readData method right after writing our temperature data and print the values to the console. Let's talk about how to handle queries more effectively. InfluxDB supports a wide variety of aggregate functions such as mean, median, max, etc. For example, to get the average temperature, we can change our query as follows. By using different InfluxQL commands, you can perform complex analytics directly on your time series data. In addition to querying, you might want to visualize your real-time data. For real-time monitoring, you can integrate InfluxDB with tools like Grafana. Grafana provides a powerful and flexible interface for visualizing time series data. You can configure it to pull data directly from InfluxDB. Setting up Grafana involves a few steps. First, you'll need to install Grafana, which you can also do using Docker. After setting up Grafana, navigate to http://localhost 3000 and log in with the default credentials, admin/admin. You can then add a new data source and select InfluxDB, providing the URL and database details we set up earlier. The integration is quite straightforward. Once you've linked Grafana to your InfluxDB instance, you can create dashboards, set alerts, and visualize your data interactively. In conclusion, we have covered the fundamentals of InfluxDB and how to interact with it from a Java application. We set up a local InfluxDB instance, wrote data to it, queried the data, and also discussed how you can visualize it using Grafana. By following this tutorial, you should be able to leverage InfluxDB for your projects effectively. I encourage you to explore more of its features and capabilities as you continue working with time series data. Thank you for watching. If you found this tutorial helpful, please give it a thumbs up and subscribe for more programming content. Let us know in the comments below what you would like to learn next.